And we will look at law of large numbers, but I really don't know what they're going to do except for explain to you the same thing that I've explained. So we may just skip law of large numbers because we've already been over it, but we'll look and see what it says. Now there's the roulette wheel that I was going to give you. Let's see what it says. A roulette wheel has 38 numbers, 18 black, 18 red, blah, blah, blah. What is the probability? What the patron spins 1,000 times? How many times should you expect a red number? Well, what's half of 100,000? 50,000. But, you know, just come on in whenever. I've already started, but that's okay. All right, you got two green ones here. All right, so number of ways red can occur would be 18 over 38, which is 0.47. You know how to get that. The law of large numbers tells us that a game is played more and more times, a proportion of times that the wheels, blah, blah, blah. 47, the wheel should come up because I'm not going to cover that. I've already covered all this, okay? That's a good question, though. This is a good question as far as A, and yeah, A is a good question. So you might want to write down example 1 right there, A, as a test question because it could be a possible. Now, you remember me going over the odds against with the roulette wheel? Okay, take this question and put it with those notes because you would say, what is winning in this one? Read A. What is winning? What is success? A red number. So what is failure? Not red. So not red would be 20 over, I don't forgot, 38. Okay? Because of the two greens. Because green is not red and black is not red. But you can't say black because that leaves the two green ones out. So that's a good question right there to use as a test question to see if you can do it at home. But put it with the, instead of B, don't do B, just do B, C, and D on the notes that we did. I think it was $18, bet $18 on 1-to-1. You get 18 back, and D was bet 18 on the odds against. I think it was $18 or $20, one of the two. Expected value. I'm not going to test you on that. You can write it down for your information. Expected value, the value of one event times the probability of one event, plus the value of the event 2 times the probability of event 2. But I'm not going to test you on that. We're going to talk about the lottery, but we're not going to talk about it right here. We're going to talk about it in the next section. So there's an example of expected value, example 3, but I'm not going to answer that. It may be in your homework. A gambler's fallacy. You might want to write that down for your information, for knowledge. I'm not going to test you on it, but the gambler's fallacy is if you've had a bad streak of bad luck, then you're expected to have good luck. Well, that's a bunch of crap. See, I didn't think there was much in 7C, so 7C, I would wait and do 7C homework last because it's not really important. Okay. Now 7E is what we're going to go in today. 7E. Now everybody in here knows how to count. That's not what counting is in probability. Counting is using numbers and multiplying them by themselves and multiplying them in sequence. That's what counting is. So if I multiply 10 to the 4th power, that's counting. All right, it's groups of 10, or 5 times 4 times 3 times 2 times 1. That's factorial, which we're going to talk about here in just a minute. Here's an example, or a whatever. Suppose a state license plate maker that displays 7 numerals. 1, 2, 3, 4, 5, 6, 7. What is the different combinations? How many different combinations of license plates? How many license plates can you make with 7 numbers from 1 to 0? You can't say 1 to 10 because 10 is what? Double digit. So you have to say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I meant 9, sorry. That's 10 numbers. So how many different combinations? Well, it'd be 10 to the 7th power. Now write that down. 10 to the 7th power, 10 equals the numbers. How many numbers you can use. And 7 is how many slots you've got. All right? How many slots are on the license plate? There's 7 slots. How many numbers can you use on each slot? 10. So the combinations, or how many number of license plates you can make, is 10 to the what? 7th power. So you take your handy dandy calculator out. Hold on a minute. Take your handy dandy, I don't want the TI-84, but it'll be good enough, I guess. Take out your TI-84 and say 10 caret symbol to the 7th power is equal to a BA number. 10 million or 1 million? What is it, 10 million? So you can make 10 million license plates, and then what would you do? Well, you would either add another digit or another slot, or you would change one of the slots to a what? A letter. And then it would be 26 times 10 to the 6th power. So then you go, okay, and we're going to change, we're the state of California, and we're going to change our license plate to 1 letter and 6 digits. So that'd be 26 to the 1st power, or 26 times, parentheses, 10 raised to the what power? 6th power. Because you got 26 letters you can use in that one slot, and now you've gone, you can make another what? 26 million license plates. And then when those give out, you can go to 2 letters, which would be 26 times 26, which would be 26 to the 2nd power. So 26 to the 2nd power times 10 to the what? Oops. Make sure you get out of the, let me delete all that. There we go. There. Times 10 to the what power? 5th power. And now you ran out of 260 million, or 26 million license plate. So how many can you make now? Well, now you can make 67.6 million. Now, by the time you get all of those added up, you can start replacing. Okay, you can transfer this, you can replace this one, you can start replacing, because you've got a good many. You've got 67, 67, that's 97. You've got 107 million license plates to choose from. Okay? Question. Now, you need to write down what type of question this is. You've got slots, and you've got so many numbers in the slots. So the slot is going to be the numbers raised to the slot power. because there's five or six different type problems in this section, and that's the first one. All right, they'll probably give you an example on the next page. Right here. How many 7-symbol license plates are possible if both numerical and uppercase letters can be used in any order? How many 7-symbol? So 7 means it's going to be raised to the 7th power somewhere. Okay? If both numerical and uppercase, blah, blah, blah. So that means 10 plus 26. So that means 36 for each slot. And how many slots are there? 5. Now, are these possible? Well, that's B. So there's 36 to the 7th power. So you can make 78 billion license plates. How many 6-letter character words, 6-character passwords, can be made up by combining lowercase letters, uppercase letters? How many is that? That's 52? 52. Numerals, well, you have to go through 10. That's 10. So that's, and characters, 1, 2, 3. 6 characters, so there's 6 slots. Now, they're not giving you any type of order, so I guess you just say, let's say that's 52, 62, 65 to the 6th power. Yep. So how many can you make? You can make 75 billion passwords. Okay. So that's one type of problem. The second type is this one. This one is the one you'll be tested on. Permutations. Actually, you're supposed to do combinations first, but this book is backwards, so let's do it backwards. I'm not going to do that. We're going to do combinations first. Hold on just a second. There we go. Combinations. Now, there's the formula for combination, but I'm not going to give you the formula. I'm going to let you look at it. There it is. Write it down. Put it in your notes. But I'm going to show you how to do it on your calculator, because it takes too long and it's too tedious to do it on the formula. It just takes too long. But write it down in case you ever need to recite it to somebody, I guess. N is always your biggest number. N is usually how many letters you got or how many numbers you got to choose from. So like the 10 numbers or the 26 letters, that would be N. The big C stands for combination. And then the R is usually how many slots. So you might want to put slots. R equals slots. So on that previous question, it would be 10 combination 7. Okay, but that's not the type of question we were doing. This one is different. This is when you're talking about the lottery. Now, there's one word that distinguishes the permutation from the combination and vice versa. And that word is, take out our handy-dandy highlighter, and that word is order. Okay? Combinations is no order. Okay, so you need to make sure, and it says it right here, order of arrangement does what? Not matter. Now this is what's going to be in your calculator. N is usually equal to the number of choices. So if you make your alarm or whatever, you get to choose your alarm. The first slot, you get to choose what number. Second slot, you get to choose the second number. And R is usually the slots. And I say slots because that's what it reminds me of. Like, you know, ever played the game Connect 4? You put the checkers in the slots. That's what it reminds me of. Slots. Now, on your calculator, if I can remember it, because I don't use the calculator all the time, pull up your handy dandy calculator, and I think it's under probability. But I have to look at it right quick and see stats. I don't think it's under stats. Nope. It's under math. There it is. Math, hit the math key, which is about the third row down, math. And you see number, and go over to probability. Right now it's right there. Hit the right till you get to probability. And there's NPR. That's permutation. NCR, that's combination. And factorial. Number 2, number 3, and number 4. That's what you're going to be using when you're talking about permutations and permutations and combination. All right, here's a problem right here. Suppose that you select 3 different flavors of ice cream in a shop that carries 12 flavors. How many flavor combinations are possible? Well, how many different flavors do they have? Huh?
How many flavors?
It has 12. So you got 12 choices, right? But you only select what? 3. So what would that be? 3 would be the slot. Now, plug it in. Well, you could plug it into this and work yourself to death. Or you could plug it in as 12C3. So you go to your handy dandy calculator and you type in 12. 12 math, probability, combination, 3. And enter. So you got 220 different combinations of ice cream that you could eat. I made me some ice cream last night without an ice cream maker. You take whipping cream, you know, heavy cream, and you put you some sugar in there and put you some vanilla in there, and then you take a bag, one of them big gallon bags of ice, and put salt in it, rock salt, you know, or just some big salt. And you take a little sandwich bag and you put that whipped cream and stuff in it, and then you put it in there and shake it. It makes the best ice cream. It tastes like homemade ice cream. I just had to tell somebody. I didn't have nobody to tell, so I had to tell somebody I made ice cream last night. My son, I don't have my son until tomorrow, so I have him for one day every other week, and then the whole week next week. So that's what we're going to be eating. I like that ice cream. And I like it because it melts. I cannot stand hard ice cream where you have to take a chisel and you have to, oh my gosh, that irritates the crap out of me. There's 2 things I can't stand in the kitchen. Hot food, I can't stand when you have to sit there for an hour. And my mother, she makes like soup and it's like 5,000 degrees. And me and my dad, we used to just sit there. Just sit. And it's like it's tomato soup. It's tomato and vegetable. It's not like it's got bacteria or anything in it. Why are you getting it up to 1,000 degrees? And I can't stand the ice cream. You get ice cream. I turn my freezer down. To when my ice cream, when it comes out, I only have to microwave it for like 10 minutes or 10 seconds.
I didn't for that, but you get a Ziploc bag and you stick the carton in the Ziploc bag. It works.
I never thought about that.
I've done it before. It works. It keeps it soft.
Must be the igloo effect. You know, inside an igloo is warmer than outside the igloo.
It works though.
That's probably
Take
why.
your ice creams off.
I'll try that. Okay, now I've got y'all off kilter now. Let's do something else. All right, so let's see if we got it right. 220, look at there. Now, if you don't have a handy-dandy calculator, then you are just what? SOL. You can go to your handy-dandy Excel spreadsheet, and it's combin equals combin. Y'all see that? And what will you type in, you think? 12, comma, 3. Close parentheses. It's a mirror. So, now, if you don't want to use the calculator, and you don't want to use the Excel spreadsheet, and you're one of these people that I would really like to use the formula, you're on your own, okay? That formula is a pain. It's a pain because you have to use your memory, and you have to use the memory as the denominator and the numerator, because the factorials cancel out, and you have to actually, it's just a pain. I'm not going to, it's like the trigonometric tables in the back of the trig book. I'm not going to even do that. You got your calculator, use it. That's what the calculator's for, not take the square root of 25. All right, so, all right, try this one. I'll see if you can do it. If you can't do it, then that means you're a failure. How many, example 6, how many different 5-card slot, 5 slots, can be dealt from a standard deck of 52 cards? And what is the probability of one particular hand, such as a royal flush? So what's success? A royal flush, right? Well, that would be 1 out of that big number. Let's say we play $500 on a hand of royal flush, and say we're going to get a royal flush. See what we'd win if we bet $500 in a poker game. So what would the combination be? 52. Now watch this. This is a trick learned in the war. Hit second. Entry. Look at there. And instead of typing all that in, you just type in 52. Combination what? 5. Now, how many royal flushes can you get in a standard set of cards? Think about it. What? 4. First of all, I heard, ooh, then you said 4. Okay, and you said 4. 4. So let's do the odds. I want to do the odds because I want to see what it comes out to be. So let me hit the whiteboard. And, oops, let me do this. Hold on a second. Just give me a second. I got to get this to where I do so much for y'all. Y'all just don't know what I have to do for y'all. There. All right, so I'm saying the probability of success is going to be 4 out of what? 259, 89, 60. 259, 89, 60. Then the probability of failure is equal to what? 259, 89, 56. Y'all help me out. Over 259, 89, 60. Now what happens? These two what? Cancel, and for odds against, your odds against are going to be 2,500 or 98956 to what? bet $500. I'm in the poker game, and I'm holding my cards, and I'm betting. I want to draw 3 cards, but I got to put my money in, so I bet $500. And you give me like 3 or 4 cards, whatever the case may be, and I'm betting that I'm going to get a royal flush. But I put $500 in the kitty. All right, everybody with me? So I'm going to type this in. Let's just do this to make it simple because I'm lazy. -4. There. And put that over what? Divided by 4 equals, and multiply that by 500. Now, if you were in Vegas, you just made a lot of money. Now, why doesn't anybody do that? Because what is the probability of pulling a royal flush? Well, let's do the math. Let's go over here and take 4. Wait a minute. Second entry. Let's see. There, isn't that it? No. Second entry. That's it. All right, no. Second entry. There we go. 52. Yeah. Right? Okay, there it is. All right, now, the probability of that happening would be 4 divided by second answer equals. So use your scientific notation. So the probability of getting a royal flush is equal to, let's see, 1.539077169. 1, 2, 3, 4, 5, 6. So the actual probability of pulling a royal flush is 0.0001539077169, or technically what? 0% chance. Mathematically, 0% chance. So you would either have to be drunk, or you would have to have won a lot of money and you were just blowing it, or crazy if you didn't have $500. One of the 3. So that's why you're not going to bet. Now, what if you progressive? Now, what's progressive? Well, each card that's dealt, you put more money in the pot. Well, what do you get to do after you dealt a card? You get to what? Look at it, Hubert. Yeah, exactly. So that changes things when you get to bet on each card, because at one point, Xavier, he has a 2, a 6, and a 7. I have 3 kings, and I get 2 more cards, and he gets 2 more cards. All right? Well, Xavier has nothing. All right? Xavier is not going to bet too much on the next 2 cards. What's he going to do? He's going to throw his towel in. He's going to fold. Why? He's got a 2, a 3, and a 7. Okay, you have nothing. All right? Now, if he had an ace or he had a face card or something like that, then yes, he might want to hold on to try to get 3 of a kind maybe, but he's not going to beat my 3 of a kind because I'm going for a full house, which is 3 and 2. You see what I'm saying? Three kings and 2 queens, or 3 kings and 2 eights, and that kind of thing. Okay? That's why you have to know your cards. Don't go into a poker game being ignorant, because what will happen? You will lose, and you'll get beat up probably. Yeah. You get beat up. All right, so that is a combination, and I just threw this in here. This is just for your information. This is odds against getting a royal flush in a poker game. Okay? I'm not going to ask you that, but I'm going to pull this over here too so we can, there we go. All right, let's go ahead and talk about the lottery. South Carolina education. Powerball. How to play. Okay, read those first two and write it down. I want you to put the first two paragraphs right there. You don't have to write word for word, but just write it down where you'll know what it's talking about. I'll make it a little bit bigger. Well, why don't I just get rid of it? There we go. Well, it won't let me make it get any bigger, so I'm sorry. Select 5 different numbers, blah, 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 and a red ball. Okay, you don't have to write the second paragraph, just write the first one. Select 5 different numbers. 5 different numbers. That means what? Slots. 5 slots. From 1 to 69, that's in the upper play area, blah, blah, blah. Then, 1 ball means 1 slot. From 1 to what? 26. So how many numbers are you picking? 6. You're picking 5 and what? 1. Now, in order to win the lottery, you have to what? Well, yeah, you have to guess numbers, but what's that called when you are doing that? In order to win the lottery, you have to blank the lottery. Play the lottery. Now, that is a distinction that you have to watch for, especially on a standardized test. Because a standardized test is not going to test you. Sometimes a standardized test can be tricky. All right? When you talk about a lottery, you're basically saying that you are playing the lottery. So therefore, that means you are buying a what? Okay? If it's asking for the probability of winning the lottery, always remember this, because on a test, it has to say whether you're trying to win or you just want the odds. One of the two. It'll say. But if they're asking what is that means that you are buying at least one ticket. So therefore, your probability is going to be 1 over the probability of winning. Because that 1 represents 1 ticket being bought. Now this is very important. When you're reading the question and it asks for what is your probability of winning, then that's assuming that you're putting $1 in at least. So with this question, the probability of winning is going to be equal to 1 over the probability of you getting all the 5 numbers and the 1 number, the Powerball. The 5 white ping pong balls and the 1 red ping pong ball. The 5 white, well, you said that 5 is the slot, so that's 5. And this thing is going crazy, doing all kinds of weird stuff. Okay, maybe I need to stand away from it. Okay, so 5 will be the slot. But how many numbers? What's the numbers we have to choose from? So that would be 69. And then, what's the numbers we choose from here? And that'd be 26. All right, now I want you to take your calculator, and I want you to figure the bottom first. Figure these two numbers. I'll do it with you. That second one is 26. 69 combination of 5. So I'm going to take my handy dandy calculator, and I'm going to hit second. Well, I've got to turn it on first. Second entry. See if it'll pull it up. There we go. And I'm going to hit 69 combination 5. That's BA number 11 238 513. 11 238 515. Is that what I said? 513. My short-term memory is awful. I'm one of those people that have to, when you tell me your phone number, I have to say it like 15 times as I walk toward the phone. But I can tell you something I did 15 years ago. My short-term memory. That's why it took me 9 years to get a math degree. All right, so punch that in. So 112 times what? 26 equals. So the probability of winning the Powerball lottery in South Carolina is going to be equal to 1 over 292,201,338. I remember when the lottery came to South Carolina. Oh my Lord. You would have thought that we were putting up prostitution houses on each corner of every kindergarten and every school in the state. Because all the South Carolinians, we're all what? Stupid and illiterate. We were going to go out and take our paychecks and give them to the lotteries, and we were going to starve to death. That's what everybody was thinking. So we couldn't have lottery. I'll never forget that. We had people fussing and fighting. Had a bunch of Bible thumpers. I call them Bible thumpers. I'm not a Bible thumper. I'm a Christian, but I'm not a Bible thumper. They were down there at the house fixing to kill people. I mean, they were just crazy. They were hollering at people, shouting people down. Wanted to bring the lottery to South Carolina. It was rough. Let's see what the odds are. Oh my goodness, look at there. 292,201,337. What did we get? Oh, they rounded up. Evidently they rounded up. Oh, there it is.
Yeah, one in, you look up, it says 1 in.
Why has it got two different? Why has it got? I don't know why it's got those. Okay, there it is. I don't know why they got these two numbers right there. But anyway, now let me show you a trick. Take your handy dandy. This is why you need to. There was a professor at Clemson, Dr. Brawley. He was about this tall, and he loved doing probability of gambling. He loved doing it. He was one of those people that he didn't teach anything, but he wrote 2 or 3 books on gambling, and then if you gave him a class, I don't care if he was teaching calculus, he would just take the middle of the class and go to probability. I mean, he just loved talking about probability. What they should have done was given him all probability classes so he could teach it all day long, but they didn't. But he ended up making everything go to probability. So by the end of the day, you were going to end up talking about probability in his class. So he wrote a book about how many tickets should you buy, and basically I'm going to show you what he was talking about. And he went into a real. I mean, I'm just showing you on a spreadsheet. He wrote 150 pages about it. Okay, but you can buy one ticket, or you could buy what? 10 tickets. You could buy 100 tickets. You could buy 1,000 tickets. You could buy 10,000 tickets. You could buy 100,000 tickets. You could buy 150,000 tickets. You could buy 200,000. Buy 300,000. Buy 500,000. Buy 1 million. I'm just picking numbers, okay? I can't use commas, sorry. 10 million? No, we'll just go with 2 million. Sorry. Let me just start over there. 2 million. There we go. Okay, so that means we got to do, let's see, we'll make N, or let's see, what was it, 69? N is equal to 69. Let's go, N is equal to 69. And R is equal to 5. No, I can't do that. R is equal to 5. N is equal to 26. And C, or R, is equal to 1. And I go here, and I go equals, come in. Oops. Oh, Lord. There. Come back. I guess I'm supposed to click on it. There, how about that door? And then 69, comma, 5, right? And then same thing here, Control C, Control V, and then that's going to be combine 26 and 1. And then I go over here and I say equals this number divided by parentheses this number times this number, close parentheses, I'm thinking F4, enter. And I copy that down. And then I go over here. And then I don't like that. Equals this. And do this again, and then do there. No, then do format numbers, and then take it to 10 digits or 15. There we go. All right. So the whole point of doing this is to show you, and you could take it right here and you change these into equals this and run this down and then change all these into percents. And Dr. Brawley's book was about when do you stop buying tickets, or how many tickets should you buy? Well, if you look, what is the probability of winning up until 1,000 tickets? 0%. Well, it's still 0% here, but that's when you start getting into what? 10,000 tickets, 100,000 tickets, and down to a million. A million, you still at 73%. But you got to think about this. What if there's only 2 million in the pocket, in the purse? So that's what a lot of people think about when they're buying tickets. How many tickets do I buy? 1. Because I've got the same shot as winning the lottery as the person that buys what? 1,000 or 10,000 tickets. So you have to think about stuff like that. And don't give your whole paycheck up and have your kids run around in their diapers in the convenience store while you're inside investing all your paycheck into the lottery because you're ignorant Southern. Oh, Lord. There was people actually got on TV and said, South Carolinians cannot handle the lottery. They will lose all their money. They will go into debt. How do we get along every day without these people telling us how to live? How do we make it every day? Some of y'all have no idea what I'm talking about. But anyway, I take offense to somebody saying I can't. That's why I have such a problem with bureaucrats. All right, you do this one. The Mega Million. There it is right there. And then I want you to tell me what is the probability of you winning if you bought 1 ticket. I'll go ahead and say that so you'll know to put it over 1 or under 1. It says select 5 different numbers, 5 slots, from 1 to 75. And the Mega Ball from 1 to 15. What is the probability? Y'all know if I won the lottery, I'd pull up in a brand new truck. You wouldn't quit your job? Nope. You know why I wouldn't quit my job? I would work for 3 months just so I could blow my check for 3 months. Just blow my check. Take my check, and once it hit just blow it. And then after I do that for about 3 months, then I quit. After I buy my retirement. I'm not going to let my retirement go. I'll buy my retirement. My last, 6 years? And then I would go to a tax attorney. A tax attorney. Accountant attorney. Say, okay, what do I do with all this money? No, I would not go to the strip club like that idiot did in Texas. Got all his money in his truck stolen, got beat up in the parking lot. Some people should not procreate, have driver's license, or win the lottery because they're idiots. He won like $10 million. One of the first ones to win the lottery. Oh. So he went out and bought a brand new truck, brand new F-350 dually, everything on it, which probably was about $50,000 or $60,000. Then he put, listen to this, $600,000 he put in the console of that truck in cash. And they stole his truck, and then later found out he had $600,000 cash in it.
They never found him, did
they? They never did. They found the truck.
Not worth not worth that $600,000.
No, I would have took $600,000 and ran. People are stupid. Okay, so you go to Handy Dandy and you type in 75. And what's the other one? 15? Okay, it didn't change. Why didn't it change? Oh, I know why. Hold on a second. Combin. That number. Wait a minute, that's Combin. I did 3. That's not right. It'd be 5. It should have been 5. Sorry. I knew something didn't look right with those. The zeros should be all the way down to 1,000,000. I knew something was wrong. There we go. I knew something was up there. Huh? Yeah, 75 and 5. And then 15 and 1. So this needs to be that one right there. And 1, that's always going to be 1. So there we go. Now, just right quick, I'm going to change this back because I had something wrong. 20. What was the number on the Powerball? 69. All right, 69 and what? 26. That's what was supposed to come up. Now, who's smarter? The person buying 1 ticket or the person buying 1,000,000 tickets? 1 ticket, because you still got mathematically 0%. Technically, you got 0% to 2,000,000, but it's rounded up.
Have you ever seen that? Do you watch Family Guy?
No.
Well, there's like one episode where he buys like 1,000,000 tickets and they win, and then they use it all up in like 2 days, and they do it again. He's like, I just spent so much money buying all these tickets, but we won.
10,000,000 scratch-off tickets in the living room, and they're just taking all of the scratches and just trash bags.
For hours.
That goes to my point, except that's in Rhode Island. You know that's based in Rhode Island, don't you? I didn't think people up north were that stupid. I thought everybody up north was smart. It was just us dummies down here in South Carolina and the South. They're everywhere. Oh my. Oh well. But that, and then you change it to 75 and what, 15? All right, see what y'all got for 1. See if y'all got that. Well, let me do this out here for you so you'll know what the number's supposed to be. Equals this times this. Here's the number you should have. 258,890,850. Is that what y'all got? Let's check with the Powerball people. Where's their odds? All right, check that one. 258,890,850. Now there's the Lucky for Life. You know what Lucky for Life is? You get paid $1,000 a week for the rest of your life.
I'd rather have that.
I would too.
Just live a little.
Yeah.
You're gone.
Or blow it, whichever one you want. You have a little bit more control over it. No, I would take, if I won 26 million, I would blow 6 million. Okay? And I would take the 20 million and invest it in different things that, doesn't lose its value, like either land, gold, or silver, or something like that. Not frozen concentrated orange juice or anything like that. Not commodities, because bottom falls out of them too much. And then I take part of the 6 million and buy me a bunch of cows and a bunch of new tractors.
That $1,000 a week is $52,000 a year.
Yeah, which $52,000 a year, after 10 years, That adds up. Okay, so that's how you do a combination. Well, what about a permutation? Well, permutation is not that bad. Permutation is almost like a combination, except a permutation, if a combination has to do with no order, then what do you think a permutation has to deal with? Order. And it should have it in here somewhere. Just put order equals order. A permutation equals order. And we'll put it in capital letters because that means you have to have it in order. Now, I'll go ahead and tell you what kind of question you're going to get with this type. Races and officers on a board. Okay, so the first one is going to be operated like a horse race. And the second one is going to be, well, you've got 6 people, and you've got 6 people that are with this group, and they want to have a board. How many different combinations of boards can you have with 6 people? Well, that would be 6 permutation of 4, and the 4 offices are president, or chairman, vice chairman, president, vice president, secretary, and what? Treasurer. Okay, now what if you did chairman, vice chairman, then that would be 2 slots instead of 4 slots. But most of the time when you're talking about offices, you're usually going to be talking about president, vice president, secretary, and treasurer. So that would be 6 permutation 4. Well, what about a committee? A committee does not have offices. So a committee would be a combination. Just remember, committee, combination. Committee, combination. So most of the time when you're asked about offices, the next part of the question will say, well, what if they just want to form a committee? And that is a 2-part question. The first part is a permutation. The second part is a combination. We'll find an example. These are the ones that's going to make up a lot of your tests. These, additive property and multiplicative property, and then basics. 4 types of questions. If I could find the little arrow. There we go. There's so much stuff on this dadgum board I can't see straight. All right. That's not the one I want. Well, they don't have one, so let me go look for one in the homework. Okay. There's one. 28. I'm trying to go away. All right. A city council with 10 members must appoint a 4-person subcommittee. How many subcommittees are possible? Well, 10 members. What does that mean? That's N. N is always your biggest number. What is 4-person committee? Slots. So that would be 10 combination of 4. Now look at number 26. What's the difference in number 26 and number 28? 26 has what? Offices. 26 says a city council with 8 members must select a 3-person executive committee consisting of a mayor, secretary, and treasurer. Permutation. So what is my slots? 3, and what is N? 8. So that'd be 8 permutation 3. But look at the second part of the question. What does it say? How many committees are possible? That would be 8 combination of 3. So that's the kind of question you're going to get on the test, something like that. 2 parts. 26 and 28, both are good test questions. There's one about a horse race, but I don't see one on here with about a horse race. Y'all see one? I remember seeing one in the homework about a horse race, but and that's 7E. So, just to go over what y'all should know for next week, and I think y'all have, don't y'all have spring break next week or something? Fall break, yeah, whatever it's called. I don't keep up with it. All right, hold on a second. So when y'all come back, we'll probably be reviewing for what? The test. So that means you should be working on what? You should be working on homework and get it all done. And I'm trying to, I can't get the whiteboard to come up. There, no, there it is. Okay. You should be working on 1. You should be working on the basic of probability. Basics of probability and odds, and make sure you do know how to do odds and ends. That's 1. 2, make sure you know how to do the additive law. 3, the multiplicative law, and make sure you know how to do permutations and combinations. Now the permutations and combinations, I'm going to try to use questions that we went over in class. But on the homework, you're going to get a license plate question. You're going to get one of those type where you raise it. You raise the number to the slot. So be prepared to see one of those questions. You raise your number to the slot power, as we went over in the first part. And that's what you're going to be. So you're talking about 20 questions, each one probably going to have 4. And the roulette question, card question, die question. Second one, the additive law. If I can get a blood type question on there, I will try to put tables so you won't have to, but that's table. Multiplicative, marbles, CD, and a permutation. You know a lottery question is going to be on there, and the combination, and then permutation will be like offices or races. Okay? Races not in I'm a racist and I don't like races, not that. But races like, you know, because everybody's racist today. So it's going to be a race like a horse race or a race of people running race or something like that. Okay? Question, great, complaint. Alrighty then. I'll shut her down and I'll see y'all whenever y'all come back, and hopefully y'all will have all your work done.